we optimize a function or procedure or method, we use the class function in LLVM. And all compilers use a number of attributes to describe properties of the function being optimized. And LLVM is of course not an exception. Here is a partial list of these attributes. And most of them are absolutely obvious that we need them, such as a pointer to the control flow graph and the symbol table, and a pointer to the arguments and how many arguments there are. I will make some minor remarks, such as if the function has a variable number of arguments, then some arguments are passed in registers and others on the stack. And it is during the execution that the function can figure out how many arguments there are. So this complicates, it gives some overhead, and it limits some opportunities for optimizations. It's better if we know the name and the type and everything of the argument when we compile the program. Okay, and the location, which register they are in. So this limits optimization opportunities and should be avoided for performance critical code. Okay, another thing which is important, does it return a structure? How can we return a structure? Well, if the structure is small enough that it fits, for instance, in 2 integer registers, then that is often used to put them there. And if it's a larger structure, then what usually is done is that we, the caller gives us an extra argument, which is the address of a structure that the return value can be stored at. Okay, so that affects how the it affects how the code generation, etc. is done. If the address is taken of a function, then that can limit some optimizations. And if the code uses setJump from C or long jump, setJump sets up a non-local goto, actually a destination that we can make a goto to. And this goto is made by a call to long jump, and it can jump into an active function. And as is very easy to imagine, this can create problems for data flow analysis, and it should really be avoided in performance critical code. And yeah, it is very annoying for optimizing compilers that we can leave a function or enter a function from unknown places. Well, not leave it from an unknown, but we don't know where we go. So that's something which is interesting to take care of when we create compilers. Okay, if we have statistics on how many times the function was called, then that is also important attributes. And if this function should be optimized for size instead of speed, that's also an attribute. Okay, so the class BasicBlock, it has a pointer to the parent function and a list of instructions. And as expected, all the phi functions, they should be first, and the last in LLVM should be an instruction of the class terminator instruction. And then there are lots of convenience types and functions to get the first non-phi function, for instance, and iterator to get through this list of instructions. And there are, for instance, functions to move one basic block from its parent to another function, or to split a basic block in two parts. These are things which are convenient to have, so it's very natural that they are in LLVM. And all compilers have something similar, or at least most have. Okay, an instruction, the operands of an instruction have the type value, and branch instructions, they have basic blocks as operands, so a basic block is also a value.